Hello, welcome to video number 6 on this Pandas playlist. In this video, we're gonna see some examples about missing values and duplicates. So let's get started. So import pandas as PD, and then data frame is gonna be pandas read CSV. Where is it? Here. And then the name of, I already have the comma separated value data imported here in our files. Video 06 CSV df. So here's our data. So as you can see, we have these cells with a text reading NaN. So in Pandas documentation, NaN means not a number, but on the columns where the data type is string, well, then it should say not a string, right? Well, we got none. So these none cells is or are where data is missing in our rows or in our columns, depending how you like to look at data frames. And just to look at this data frame, let's just see it printed. And here it is printed with, and we also see this NaN. And let's return to regular data frame or data frame dot head. So we just have 5. And if we send it out data frame to CSV, what happens if we test CSV? What happens if we send out a data frame with nones? So we are gonna get empty cells. So it's both ways. Something interesting or fun here in our terminal. The terminal is already at a content directory. So if we ls, we see the test CSV cat test CSV, and here is our text, comma separated value text, right? And here we can see the nans. Where are they? Here, an empty spot, just 2 commas with nothing in between. And Beam, has this Beam installed. So text CSV. Here's our comma separated value text. So here's another place where we have our emptiness. Okay, so that was just a little detour to show this terminal. So back to our video. So Pandas has this built-in null finder or checker. Df, let's print it. Print, and then let's print df is null. Sorry, we need parentheses. And here it is. It printed a whole data frame and assigned true or false whether the cell is empty. So this is just for illustration purposes because this is very messy to look at, right? And if the data frame would be very big, so it's even more messy. So some actual command we could actually use is this dot sum. We apply the dot sum on the is null and see what happens. Here, we got a series where the index is a string with the name of the column, and this integer is the number of cells where there's an empty space on this column. So for example, bounty column has 2 empties, age 3, hometown 4, etc. Another useful one would be, let me just copy this, and instead of asking for a sum, we ask for a mean. And we get a fraction or a percent. Well, to see it as a percent, we need to multiply by 100. So this means that in this column, 15%, 10% of the data is missing. In hometown, we have 20% of the data is missing. So this is already a little analysis to do on our dataset. Now, to see how many overall, then df is null, and then we do the sum. We already did this, right? And we got the each. But if we do a sum of this series, then we get a, let's print this. And let's print like this. Total missing space. All right, so total missing 11. And then let's do the same thing, but with the mean. We get a mean of the mean. So a mean, this first mean is a mean of the data frame, returns the series. This second mean is the mean of the series. This is percent missing. And then we multiply this by 100. And then we specify 0.1 f. Is this correct? No. No, so we need to print this as an f string, and then everything, and then this whole thing. No, this whole thing inside curly braces. And then will this work? Yes. And like this. No, this inside curly braces evaluates Python, so the percentage should be here because we're just printing some text like this, 6.1%. All right, that was messy, right? And another one is, let me just do another cell and then the shape from NumPy. df dot, it's like this, df dot shape. So we get a tuple. And this is there a, well, in order to multiply here the 0 and then copy times, and then this will be the second one. So this will be the 20 and this will be the 9. No, because this tuple index is out of range. Sorry, this was a 1, 0 and 1. And there we go, the total. So again, we just to print and then let me just cut this out of here and paste it here, run this, and there we go. Total missing 11, total cells. So this is the size of our data frame, and this is the percentage missing. So there we go. A bit messy, but we did it. Okay, so let me now let's do the whole df. So what do we do with the nans? Well, we have a few options. So either we fill here with something, sometimes when it's, or we decide to completely eliminate the rows where we have empty, so it does not mess our statistics, right? So let's look at some examples of dropping the nans or deleting them. So there's a built-in function for this, df drop na, and drop na has a lot of options. We will look at them, but if we just leave it empty like this, this will return a new data frame with the rows where there is a nan eliminated. Like, for example, here at the very bottom, 2 of the Arlong Pirates has a nan. So when we run this, so we only get dot, what was the command? Dot shape. So we now have only a 10 by 9 instead of a 20 by 9. The full one is 20 by 9. So with the drop NA, we dropped 10 rows, right? So we are left with very little data. So maybe in this example, if we want to do some things, the best option is not to eliminate it because we are left out with only half our data. But anyways, that's up to you. One of the other drop NA options we saw is the how, and then a little any all. I guess the default is any. We will see how equal to all. So this will return the same data frame we had with 20 rows because if we specify the how to all means it will drop rows where everything is missing. That we have like an empty row, which is garbage, trash data, garbage, junk data, right? Okay. Another useful one, drop NA and then subset. This is an important one. And subset takes a list of columns. In this case, we'll use age as an example. So it will drop the entire rows where on the age we have an an. So Buggy will be gone. We are sorry, Buggy. So see, from 4 jumps to 6. No more Buggy on our data frame. And I guess if we do, and then hometown, we drop where we have nans on the age or on hometown. Now, this whole thing was dropping rows if there was an an on the row. But what if we want to drop a column if it has an an? So there is also an option in this drop NA. df drop NA and then axis equal to 1. It left us with the columns where there is not a missing value. Another of the parameters we can use in this drop NA function, drop NA, is this thresh equals, takes an int, three. Let's do 8. So this data frame has 9 columns and 20 rows. The threshold for dropping or for keeping is, depends how you look at it. We need at least 8 values. If it has 8 and only 1 nan, we keep it. If it has more than 1 nan, we drop it. So in this case, 18, 16, it was the 11th. Let's just look at the df again, full. Here, Mohi had 1 and 2. So 1, 2, 3, 4, 5, 6, 7. Only had 7 values. Did not meet the 8 value threshold. So that was just too many nans for us, right? So sorry, we had to delete the row. So just as a reminder, df.dropna returns another series. If we want to change our data frame, we need to reassign it or do the in place equals true. This is one method, one option. The one I have commented earlier, that df equals df dropna, and then from here on, if when I refer to our df, it's this shorter one. So now I already changed the data frame in memory. So in order to bring back our full data frame, I need to run from the top. So we re-import it from the CSV, or import it again over here, whatever we prefer. Okay, so we mentioned that we can do two things, either remove or fill in the data, fill in the missing value. So we have another useful function, which is fill na. So to use it, we will do this. df hometown nan df hometown returns the series or the data of our hometown column, right? So then if we fill na, fill the nans with the string I want to put in here, right? So hello world. Yeah, that seems appropriate, right? Hello world. Hello world. And of course, if we df equals df hometown equals this, then what did we do? We changed our data frame to put hello world where there was a missing value. So I think that's, well, this was just for entertaining purposes. So let's run it from the top and place here unknown. So this seems more appropriate. Anyways, let's continue. So we can also replace missing values with this fill na. Can be inside the parentheses. We can do numeric stuff. For example, let's mean of the age is equal to the age dot mean, and let's see what this is. Let's assign it any df age is equal to df age dot fill na with the mean age. So good old Buggy the clown will now have an age of 25 years and some months, 25.9. Well, not only him. Everywhere on this age column where there was a missing value, now we have what is the mean. And maybe this is for statistical purposes, right? So I don't delete this example. Let's df equals read CSV. Okay, so now we have the data frame back from the CSV where Buggy has no age. So now let's instead of mean, we do median. And here we go. dfh dot median is our median age. And we are going to replace the column age with this median. And now Buggy is 26 instead of 25.9. So this is the difference between the mean and the median on this data frame. Sometimes we decide, well, here we decided to do this, right? Sometimes we might be more appropriate just to df and fights 1 equal df fights 1 dot fill na with some constant. So if fights 1, if we decide that the column fights 1 has none, we will assign 0 fights 1 to that guy. So let's do that. So Helmpo, the Marine recruit, never won a fight. Sorry, Helmpo. I feel sad for you. Okay, so now the real juicy one. Let me just copy this so I do not struggle a lot like before. Copy paste. So we bring in again our data unchanged data frame. So now we are gonna df equals df fill na, and then we are gonna do a dictionary. And we are going to specify for each column what we want to fill it with. So let's bounty with a 0, hometown with unknown, age with the mean. No, we did not like the mean. We like the median better, right? And finally, fights 1 with 0. So these are the examples we did, but we decided to do it from the get-go with a dictionary specifying. So fill_NA can take a dictionary with key value pairs, the key representing the column name and the value representing with what the empty cells would get filled with. So here we go. Boggy gets 26 years old, and where there was an hometown, we get unknown, 0 fights 1, and the bounties also. If we had Nan as bounty, we placed a 0. Well, it displays, curiously, it displays it with a decimal. Fights lost without a decimal. So let me just df.info, and apparently when we fill NA, even with an integer, it replaces the value, the data type, to a float. Let's go all the way to the top. df.info, and we run all. Now they were already floats from the get-go. And I am not sure why. Maybe because of the missing data. I'm not sure. Okay, so I just Googled it on another screen, and yeah, when we import a data frame where it has missing values, Pandas makes that column a float, because if it's just integers, it cannot store the nan. So anyways, that's a new one for me, or a reminder for me. Okay, let's continue. So let's scroll all the way back to the top, and let me delete that cell, a new cell. So what's next? Let's bring in our data frame again, h.ff fill, and we are not going to do the in place equals true. I'm just going to show this. So this returns, and remember number 5 was buggy, he was empty. So with this f fill, which means forward fill, it copies the value directly above. And if we do bfill, it fills with the value directly below. So now this guy is 26 instead of 19. And we could do the fill_NA method, the forward fill, on the whole data frame. Like this. Or the backward fill, but in this data frame it would not be appropriate, right? Because maybe we could get away on the ages, so we can if they are like in order, we will get if we have like ages from younger to older, so filling with the next one might be suitable, but filling a hometown where we did not know it, filling it with the guy next to him, well, that would be inappropriate. That would be false information, right? So this forward fill would be suitable in some cases, right? Okay, so now let's look at some examples where we don't have missing values, where we have duplicated values. So let's first, let me create a CSV with some duplicated rows. Let me see if I can get away with it in the terminal. List, yeah, let's see, Vim, and then it's video 6 pilots. Okay, and then let's duplicate this, shift this tree, we yank, shift G, paste, colon W, colon quit. Let's see if it worked. That was some Vim magic. So let me bring back our trusty parrots CSV and df dot shape, shape is an attribute, not a function. So here we go. Now we have 23 rows, the same 9 columns, but now we have 3 rows duplicated, right? Because I copy paste, but I did it in the terminal. So the first 3 rows, Luffy, Zoro, Nami, we have them duplicated here in the back with different index number and all, right? But the entire info is duplicated. So Pandas has a built-in function to find this duplicated. Let's see what this throws at us. So it throws a series where with a boolean true where the row is already somewhere else. So we can use this as a mask. df. So it only displays the rows on our data frame where on this series the value is equal to true. So this command displays the duplicated rows. So we could also count them. df dot duplicated, like we did with dot sum 3, and if we np this is a numpy thing, print. So this returns 3, which is the number of duplicated rows, and like we did on the percentage times 100, well, as we can see, 13%. Okay, I will just use the syntax again as we did before, just so we can read it with only 1 decimal. So just to see how this works. So, okay, so how do we delete this duplicated? So it's df drop duplicates. So once again, we have only 20 lines. This returned a new data frame, remember, because if we df, we see we have our duplicated lines, Luffy, Zoro, and Ami duplicated. So again, if we want to assign this, we can in place true or reassign it. df drop duplicates, and then here subset equals, and specify inside the list where only the name column has duplicates. In this case, everything was duplicated, right? But we could specify remove duplicate lines where we have the same username, for example, and then this would give us the same result. So anyways, I think that will be it for this video. Hope you enjoyed it. See you on the next one. Thanks for watching.